Okay, so here is the chapter. We have the trigonometry chapter. Now, I'm not here to teach you sine, cos, and tan, and Pythagorean theorem, and sine and cosine law like you've never seen it before. I'm trying to find a healthy balance between reviewing and just reinforcing the stuff that maybe you're a little rusty on. So let's not get too concerned about the difficulty level, because it will be fairly straightforward, the questions on your exam. So what are we going to do today? We're going to review the Pythagorean theorem, just one example. We're going to talk about sine, cos, and tan. We're going to do a few of those. We're going to do a couple of application questions of sine, cos, and tan. Then by that point, we'll probably take a break. Then we're going to talk about sine law and cosine law. First cosine law, there you are. And then after cosine law, we're going to just do some problem solving, maybe a few questions. We have a quiz today, Victor, yes. On last week's material. Okay, and then after that, there is a couple of more topics here which we're not covering. So I want to emphasize here, just take it in your notes here. See, okay, make sure you take this down. 5.5 and 5.6 on radian measure, those are not going to be on your test. These are topics that sometimes I cover and sometimes I don't cover, depending on the time that we have allocated. Being in an online format makes it's a little bit harder to go through as many topics, because it's monitoring the chat and doing other things at the same time tends to slow down the lesson a little bit. So for that reason, I'm not going to cover radians for the course. But for those that are interested, I can definitely post some educational links on it for those that are curious. And also, I put the solutions on Blackboard. They're not hard things to do. It's just I want to be careful that we cover what's most critical for you to do well in the program. If you don't know radians, you can still study this program. That's what I'm trying to say. Okay, so let's get on with it. Let's talk about our first application questions in trigonometry. No, radians not on midterm. No, Mario. So just take a look at question 1. This is the only question that we'll do today that involves the Pythagorean theorem. I have the solutions on a separate tab on my computer, so I'm not going to be writing down a lot of algebra. I am going to do is I'm going to copy and paste some of my solutions, and then I'll discuss them through annotations and modifying the diagram. So for this question here, your objective is to find the height of the cone. So this question, we're actually looking for this height. I can call that h. And if you extend the base here, there's a triangle. So we have a right angle triangle. Now, since this question only involves sides, no angles, you're going to use the Pythagorean theorem. Thank you, Shazad. Very nice. So, only sides involved. It's a right angle triangle. Pythagorean theorem. That's my thought process with this question. So you could write here a squared plus b squared equals c squared. But I think it's actually better to not use letters that are not in the question. So I ask you, in this triangle, what is the longest side on this triangle? Is it the h, the 14? Okay, it's the 14. Very good. So I'm going to just draw here a 4, because that's 4. Whoopsies. Sometimes the stylus here doesn't behave, as you know. That's a 4. So all you got to remember is that the 14 goes by itself. We have h squared plus 4 squared equals 14 squared. And then you can, you're gonna just see me like I'm gonna do a screen capture of my solution and just drag and drop it here, okay? I'm not trying to cheat. I'm just trying to save a little time on the easier questions. So hopefully that's acceptable to you in terms of the delivery today. Thank you very much, everybody. Your feedback is fantastic today. So let's keep it up. We're doing really well here. So I don't think anybody's too stressed out about Pythagorean theorem anyway, but just make sure you don't forget the square root here. And the answer is, it says in the question 3 significant digits, so that's why I have 13.4. Also, the units are in centimeters. On your, as you've seen on the computerized feedback form for the midterm and for the quizzes, you don't have to explicitly type the units in your answer. So usually, sometimes, maybe on occasion you might on this test, but I doubt it. If you do put the units in the box, it doesn't affect it because I'll read it over anyway. So that's enough of Pythagorean theorem. Now we're going to talk about when you have angles. So in order to talk about triangles with angles, we need to remember the labeling procedure. So here's an angle, and this angle is a reference. Also, we have a right angle here. So when we label the triangle, the side that's opposite the right angle, what is that called? Is it called opposite, adjacent, or hypotenuse? Yeah, it's hypotenuse. So I'm going to put an H there just because I don't want to write the word every time. Then we have to figure out opposite and adjacent. Opposite and adjacent, it depends on which angle. So we're using this angle as a reference. So this side is opposite. And that's O. Oopsies. So, sorry, my stylus is a little bit misbehaved as usual. It's like on a different time scale or something. And then this side here is adjacent. So that's just a quick refresher about labeling the triangle. Nothing too dangerous there. But once you do have the triangle labeled, then you're able to write down this famous acronym, SOHCAHTOA, which stands for, what does it stand for? Let's remind ourselves. So earlier in the document, I actually write down the actual meaning of this acronym. So that's the acronym: sine, cosine, and tangent. Okay? So I'm not trying to intimidate anybody or put them on the spot, but I'm pretty sure there's a few people here that might be rusty about sine, cosine, and tangent. You don't have to tell me in the chat, but if you feel comfortable, let me know in the chat. You feel rusty? Well, Brian, I'm going to make you increase my YouTube views. I'm just kidding. No, Brian, for real. No, Brian, for real. Here, let me help you out here, okay? And some other students. I have my YouTube channel, as you know, where I post the solutions. I'm not trying to sell you for YouTube views. I couldn't give two craps about that stuff. But what I do want to mention here is there's a video that's perfect for you. If you're rusty, or okay, if anybody here has anybody like siblings or kids or whatever in grade 10 and they're hurting on their trigonometry, I made a video for the diploma students for the construction school, but for the diploma, the engineering technology, it's right here. It's called right angle trigonometry. If you want to get better and you want to practice, watch this video. I promise you, it'll make your day a lot better, okay? Thank you, Ravina. So I'm just telling you, I'm not trying to sell you stuff. You know, I'm not trying to sell you a YouTube channel to get another like here. Who gives a crap about likes? All I'm saying is watch this video, okay? So then I can put that screenshot in the actual document here. And this link is available on Blackboard as well. I promise you. Subscribers, no. Syed, I don't know, man. I don't even know about the subscriber stuff. I don't even know what that means. All I know is that it's helping people, so it's good. Yeah. You know, I mean, I got a good job. I'm teaching, whatever. I have my stuff. Yeah, it's gonna change my life. 199 views is gonna change my life. I know. Anyway, I'm honestly, guys, I might have told you at the beginning of the year, I made this YouTube channel for my niece because during COVID, she was terrible mark in math and she lives far away. And I made the video. I was like, well, you know what? Why don't I just make it public and share it with other people? And and then the George Brown videos, I put them on here because you on the road to 1 million. Yeah. Anyway, let's keep on going here. I'm sorry, I'm off topic. Definitely, that is rewarding. That is the rewarding part, Ravina. Brian, did I lose you there? What do you think about that video? Do you think you're gonna watch it? Where are you, Brian? Are you hiding? I'm glad. I promise you, I'm not. You'll see that it is a very good video to watch if you're really rusty. Not you, but anybody that's maybe on in the shadows that's like doesn't want to say that they're scared, they remember or whatever. It'll help, I promise you. Anyway, okay, let's get back on track here because I'm yapping away too much. And I haven't even had a coffee today. Okay, so here's question 3. Now, the question here is to find the length x, but there's an angle involved. So now we have a right angle, and we can't use Pythagorean. So then we got to use SOHCAHTOA. That's the logic here, okay? I'm going to be cutting and pasting my solutions from the notes. But what I'm going to be typing in here and presenting to you is the logic, why I'm making those decisions. Because I think students, once they see the math part, they can execute it. You guys as a group are very good at doing the algebra and finishing questions. The setting up sucks. And that's not just anybody, that's everybody. Even when I was a student, if I made a mistake, it was setting the thing up. So in order to solve this question, we need to consider using sine, cos, and tan because we don't have the hypotenuse and we don't care about the hypotenuse. So in this case, well, let's label it. So that's the hypotenuse. This one's opposite. Remember, it's opposite the 35 degrees. And then this leftover side here, I'm just going to call it A because it's adjacent. Some people here, maybe English is not their first language. The word adjacent means beside. So 18 is beside the angle. And yes, Ali Akbar is on point right away. Shazad with a close second. Sorry, buddy. Ali Akbar got you on this one. Quick to the draw. Here we go. Okay, so let's write down the appropriate ratio. So ahead of the game there, the question is, which ratio do you use? Well, when you look here, we don't care about the hypotenuse. So we need to think about the ratio that involves O and A. So the ratio that involves O and A is this one. So you have to decide which one it is of the three. You could write down SOHCAHTOA on your sheet. I know some people in the chat have already answered the question, but please allow me for the first couple to go really slow. So you want to use this one because you have O and A, and we don't care about H. You don't care about H, so you throw away the ones that have an H in them. See the H here? You don't want to use them. So that means we're going to use tan. So tan of 35 is opposite over adjacent. And then that's OA, TOA. So then what you want to do is simplify that or solve for x. So what I mean by simplify is some of you might want to type tan of 35 on your calculator, whereas others might just want to deal with it later. So my preference is, and you don't have to do it my way, my preference is just to cross multiply. So I'm just multiplying these two guys together. And if you're like cross multiply over here, where's the fraction? There's a 1 underneath. Remember, there's a 1 down there. So it's 1 times x. So that's how you get this. And then you just type that stuff on your calculator to get the answer. I should mention here, see the 35? Make sure your calculator is in degrees. Make sure your calculator is in degrees because if it's not, you're going to have a big headache. Because all the numbers are going to be coming out wrong. So that's an example of using sine, cos, or tan. And in this case, you're solving for a side. Notice the placement of the x. You see the x is on the top here. Sometimes the variable could be on the bottom, and that represents the two possibilities of questions. So example 4 is deliberate. I'm being very surgical here. Like, I'm only doing the questions like very like custom, so that you don't have to study like 20 things when you can understand it with 3 things. So the second here is going to be that the variable will end up on the bottom. So let's take a look at this next example and make sense of it. Let me see here. So yes, it is Brian. Yes, Shazad. Nicely done. You're still gonna watch my video, right? I'm just kidding. I'm just kidding. Just kidding, buddy. Okay. Anyway, okay. Sine of 25. Let's talk about it because some people might be lost. So, or not lost, but like rusty. That's the hypotenuse. That's the adjacent, and that's the opposite. Remember, the opposite is opposite to the angle that we are interested in. Now, I want you to tell me of HOA, which one of those 3 do you not care about? Which one do you not care about? Do we care about A or A? Yeah, we don't care about A. A is garbage, right? I mean, not trying to be mean, but I don't care about you. Go away. So which ones have the A? Boom, you're gone. Garbage A. There you go. So what I did here was something pessimistic. In other words, I was doing it indirectly. So you can figure out what to do directly by just saying, I need those, or I want to involve those sides. On the other hand, you could be like me and be pessimistic and do it like being negative, like, oh, I don't want the A. Let me just cross them right out. It's somewhat satisfying when you do that, isn't it? I don't know. I find it kind of satisfying. Anyway, let's drop this in here. So there's my solution. So sine, as was mentioned very cleverly by a few students right on. And oops, just a second, my screen was reloading. Okay, so notice this time the variable is on the bottom. So that shouldn't intimidate you too much. So that's opposite, and that's hypotenuse, as per the ratio here. But wait a second, what did I do here? What magic did I do here? So this is something of an algebraic trick that I taught you in the first week. See, yes, it is cross multiplication, but it's a weird form of cross multiplication, Shazad, isn't it? What I did was I took these 2 guys and I switched them. I did that. And my reasoning for that is because when you have an equation like this, let's write it down over here. You have A over B equals C over D. What happens when you cross multiply? Can someone tell me what you get when you cross multiply that? A what? How does it go? Cross multiply? AD equals BC. Beautiful. Okay. It's okay. You meant to put an equal sign. I gotcha. Okay. What I want to say is this. Very important, people. If I take the A and the D and I switch them, if I put the D here and the A here, do you still get this? Is it still the same answer? Is it still the same second step? What do you think? Of course it is. Yes, it is. So you know what you just did there? You swapped them diagonally. You switched them diagonally and you got the same answer. So that's what I did here. I took the x and the sine 25 and I switched them. If you don't like how I answered this question, you can just turn sine 25 into a decimal and cross multiply and do your casual thing. But the way that I'm doing it, I minimize the number of times I touch my calculator. I find that most mistakes are made because you get the calculator, you pick it up, you do something, you put it down, you get it, you pick it up, you put it down, and then by the end of it, you're more likely to make a mistake. So the way that I do it, it minimizes it because I pick my calculator up once, and I punch numbers once. End of story. So that really is the both cases in terms of where the side is located. So it could be on the top or the bottom of the fraction in the algebraic steps. Let's find us a question where we're solving for an angle. So now we're going to solve for an angle. So just give the next question to read there, and we'll talk about it briefly. So there's the next question. It says determine the angles okay, I'm saying it in Greek. I mean, for those that don't know, my background is Greek. So I have a license to speak Greek. So anyway, here, alpha and phi. So those are the Greek letters if you were curious. You probably knew the first one, but maybe you didn't know the second one. So we're going to solve for an angle here. So the big reminder here is that when you want to solve for the angle, you need to take the inverse. In this case, yes, Peter, thank you. Perfectly on point. So we're going to use we're going to do the sine law after, but yes, Shazad, you could use the sine law here, but you'd have to get the hypotenuse first, Shazad, if you do it your way. Okay? If you want to do it your way, you got to, because you don't have enough information with the sine law yet. We're going to cover the sine law after the break, but if you want to use sine law, you got to get the hypotenuse here first, unfortunately. So let's go back here, and we're going to label. Now, I don't care which one we solve for. So we could solve for the first angle, like we could get this one or this one, the first or the second. I just picked this one here because it was the first one I saw on the screen. So I'm gonna solve for that angle first. So because we have that angle, we're gonna label it this way, opposite and adjacent. And the ratio is tan. So whoever said tan was correct. That was good news. Now I'm not gonna go as slow as I did before because I mentioned it enough times about SOHCAHTOA. So there you go. Tan of phi, that Greek letter there, is opposite over adjacent, so it's 1 over 2. And the big step, that's O here, and that's A. So what you want to do is you need to get tan to the other side. And that's what I was talking about. If you want to, okay, I'm saying it kind of childishly. If you want to take tan and you want to, so to speak, move it to the other side, you need an inverse. Because what you're really doing is taking the inverse tan of both sides. And once you have that, you get the answer, which is 26 degrees, 26.6. Now, to finish the triangle, what's going on here? What did I do here for the second part of the answer? Why is there a 180 here? What the heck's up with the 180? Why is there a 180 there? Can someone tell the class? It's less dangerous than that, Brian. Yes, 180 in the triangle. Remember, thank you, Kiara. That's right. All triangles add up to 180. Remember, the angles add up to 180. So we have 180 minus 90 because there's a right angle right there, and also minus that Greek letter that we just figured out over here, the 26. So this Greek letter here, we already know the number. I mean, I could just write 26.6 there. That's 26.6. Okay, so hopefully that was somewhat enlightening and made sense. So there you go. We did Pythagorean. We did sine, cos, tan. You're welcome. We did sine, cos, tan kind of mixed up. We did an angle. We solved for a side. And we saw this is basically every single algebraic permutation that you can see with SOHCAHTOA. So why not just do a couple more questions before we have a break, or a few more questions, depending on the time. And then we can sit back and take a nice break and have round 2 on sine and cosine law. So here's the next question. It's just more of a construction related question in the sense that you have physical measurements for length that involve a mixture of feet and inches. So maybe this represents the sloping side of a roof, and then this is representing the base of the roof, and you're trying to find the angle of elevation of the roof. So we're going to refer to angle of elevation again in this question, in this booklet, I should say. So we'll get to that eventually. Anyway, in this case, let's take a look here. We have, let's label the thing here, right? It's a right angle triangle. You're trying to find an angle. So this guy here, what is it? Is that opposite, adjacent, hypotenuse? Which one is that? Thank you, Brian. And the bottom one here, is that opposite or adjacent? Thank you, Melody, on point. Okay, so there you go. You got H and you got A. Now, I don't know about you, but we got to fix that feet and inches garbage because it's not working for us. So just remember, 6 feet 2 inches is the same as 6 times 12 plus 2, which, if I remember correctly, is 74. And then the other one, 6 feet 8 inches is the same as 6 times 12, 6 times 12 plus 8 is 8, so 80, I think. Pretty sure those are right. I checked them earlier. So anyway, okay, some of you might be like, hey buddy, why don't you just put them in feet? The reason I don't like feet, although nothing wrong with feet, I don't like feet because I have decimals and I need to pick up my calculator. I told you, I don't want to touch my calculator until the last step, if possible. So now that we have that, which ratio is that? Is it sine, cos, or tan? Please tell me. That is correct. It is cosine. And there you go. Now you're laughing. So this first step here is not, see what I mean? 6'2" over 6'8". Like how the heck do you divide that? You can't cross the 6's out. So you know what I'm going to do? I'm going to hide the evidence. See you later. That's what I would do. That's exactly how I would solve the question. Because mixed units are not really helping us. So this guy over here is 74. The units are inches. I can just take those inches off there, and this is 80. And there's the 0. Oh my God, this is so slow. Sorry. Anyway, 74 divided by 80. There you go. So that's enough questions involving diagrams. I should tell you for your midterm, I'm pretty sure that any trigonometry question that you get on the midterm, I give you the picture. So don't worry about drawing pictures. So at least for the easier ones. So let's go to example 7 where you don't have a picture. So now you got to think about it yourself and kind of design a picture. So maybe I'll just leave it there. So it says here, on a level ground, a tree casts a shadow. Okay, so we got a tree casting a shadow. If you're not sure if it's a right angle triangle, the word level here implies that the ground is this way. I'm pretty sure that you can assume the tree is vertical. Like, don't worry if the tree is like this. The tree is not slanted. Just draw the tree straight up like that. There's your tree. And there is, well, that's supposed to be a triangle, but obviously my stylus is not behaving today, as usual. Anyway, here's the sun. There's the pretty sun. Let's just put some nice rays on it. Okay, that's excessive, but it's kind of satisfying. Anyway, how tall is the tree here? It's 12. How long? Here's the shadow. Here's the shadow. That's 85. There's 85. So anyway, we want to find the angle of what the heck is that? Angle of elevation. Is that this angle here? Is it the high angle or the low angle? Thank you. Thank you, Brian. Right on point. He is a psychic. Okay. So there you go. We want to find this angle here. Success. So let's label this thing. Okay, so Who's going to chime in here? Is this opposite? Yeah, that's opposite. This one here, is that hypotenuse? What's this one down here? Yeah, I'm trying to mess you up on purpose. Which ratio? Is it sine, cos, or tan? Please enlighten the class. Uh-oh. Sine, cos, or tan? All right, I got a sine and a tan. Okay. It's okay, Syed. I just was waiting for a democratic response. Basically, I take the majority vote. So it was between two students. Once it got down to, it's a 3-1 now. So I think it's a, and I think Syed switched sides. Wait, why not sine? Because there's no hypotenuse. Wait, there's no hypotenuse, Brian. Remember SOHCAHTOA, right? Let me write down that buddy over here. SOHCAHTOA. SOHCAHTOA. We don't want H. Okay, I'm gonna be a mean guy now. Ready? Let me be mean. I don't like hypotenuse here. Hypotenuse, go away. Because the hypotenuse is not part of my discussion. It's all good. You're a brave soul for chiming in there, my friend. I like that. Okay, so that's tan. Now, by the way, in construction, what's a famous thing that you do in construction a lot is slope. You do a lot of slope. You do a lot of rise over run. So notice this thing here. This is like rise over run. You see that? Rise over run. So it turns out that of all the ratios, sine, cos, or tan, the one that you see the most of, disproportionately, I mean, to the average, is tan in construction. So the next question is just another one of these types of questions. In fact, I would be so inclined, pardon the pun, that I could just copy the same question down. It's the same thing. It's the same question. See, in this situation, the road is rising how much? And how much is the run? What the heck? I'm trying to get rid of these like weird dots. So the wait, for tan inverse, what do you put on your calculator? Okay, very good question. So on your calculator, there's a button that you put shift or second function and tan. Tell me if you figure it out first, okay? Joseph, sorry, I was just reading the chat of like 4 things. What is the program that you use to type the mathematical solutions? Okay, so this is what I'm using here is PowerPoint. This is PowerPoint. So to answer Ravina's question, Ravina, just quickly here, we can talk about it if you want after the quiz too. What I do is I make a text box, and then I go here and I go insert equation. See that? Insert equation. And then I can type equations and click on crap over here, symbols. Now, the thing is I'm too lazy because I'm an engineer. I don't like to type this insert equation all the time because it's annoying. So there's a shortcut on my keyboard that I have that I just, whatever it says there, I think it's command equals. Okay, another thing is I'm on a Mac. I'm using a Mac. So on the Windows machine, it might be different for Office, but the equation here is control equals. But I think in Microsoft Word or PowerPoint as well for PC, it might be a little bit different. So there's your technical support for the day. So welcome. So in this case here, we're talking about a 6% grade, which represents a 6-foot rise for a 100-foot run. And I'm sorry, people, it's just this stylus thing is so slow. It's like having a Ferrari where you can only drive in first gear. It's so sad. Okay. And not that sometimes the way traffic is in Toronto, you can't get past first gear anyway on most cars. Anyway, let's go over here. So there's the actual answer to the question. I didn't write it down. Notice I didn't write 6 over 100. See over here? That's 6 over 100. That's 6 over 100 right there. And then the reason I didn't do that is because there's a formula that I want to present to you, which is really cool. It's right here. I'm sure you've seen it back in ancient times. Slope equals rise over run, if I spell it correctly, which equals percent grade, which equals tan of theta. What I'm trying to say to you is every single thing that I wrote there is equivalent. All of these things are the same. And it's just a neat thing for you to know. So I'm going to make it a nice yellow box because that is exciting. I'm doing that because in construction, you got to know this. You got to know percent grade inside out. Okay, so we are, I'm going to put a picture from everyday life there for a second, then we're going to take a break. Let me just open up a new window here. Sorry. So those are percent grade signs telling you how much the road slopes. Now this 8% here is not the angle, it's just a percent that you could convert into an angle using the process that I've presented here. So it's 1:48. It's a little bit early, but I want to mention this question over here. Okay, this question here is not for the test. Like this is just a novelty question. Okay, not for test. Maybe not on test. This question: what is the circumference of the Arctic Circle? Even drawing this question might give you a headache. So I'm going to try to use like some screenshots here. Yeah, trying to draw this by hand with the stylus is not going to happen. So there's our Earth. Our Earth is roughly a sphere. It's not exactly a sphere. It's a flattened sphere if you want. Like someone stepped on it. Not really, literally. And the question here is, what is the circumference of the Arctic Circle? So let's just say this is north up here. And what they're asking for is this. They're asking for the, I can't draw this without like ruining my stylus thing here. Looks like I survived that. Sorry people, I have to go really slow at drawing this. I feel terrible doing this to you. Okay, there's the Arctic Circle. We want the radius of the Arctic Circle. What are we given here? We're given the latitude, which is this, and we're given the radius of the Earth. So the radius of the Earth is here. So that's 3960. And then we want this. So what we need to find is the radius of the Arctic Circle. So let me just type that here. I should capitalize that. That's the process. So we're going to find the radius of the Arctic Circle, and then we're going to use the circumference of the Arctic Circle formula. So anybody remember what the equation for the circumference of a circle is in terms of the radius? What's the circumference in terms of the radius? Probably not the best memory at 8:44 in the morning. Yeah, both of you are right. Graham and Yazan are right. Stephen, everything's good there, okay? Now, I'm not going to put pi times the diameter. I'm going to put 2 pi r. But pi times the diameter is absolutely correct. So good work, everybody, okay? And I'm going to call the radius of the Arctic Circle, for obvious reasons, r. So the reason I did that is because I want to color code to the question. So the radius of the Arctic Circle is this thing here. Oh, come on. The stylus is killing me. Okay, that's r. Remember what I said, that the radius of the Earth is 3960? So I'm going to tick it off like that. And then I'm going to also draw a radius here, because anything that emanates from the center of the Earth and touches the boundary on the sphere, that is considered a radius. So we can do that here as well. So that's a radius there. And then we're in business, because now you can just construct a right-angled triangle. There's your right-angled triangle. And the only thing that we need to discuss now, so this is 3960 as well. So I'm just gonna cross that out. Let's get rid of that. So all you need to do now is figure out something with the angle. It refers to the latitude of the Earth, the Arctic Circle, as being 66 degrees and 32 minutes. A little comment about that. This is why it's not on your test. So 66 degrees and 32 minutes. Think of like minutes as being like hours and minutes. So this would equal 66 degrees plus 32 over 60. Now if you reduce that and make it a decimal, then you get the following decimal here. You get 66.53 forever degrees. So that's the angle there. And that angle, I'm going to just, let's do this. Give it a nice orange color. Or peach, I guess that is. And that's the angle right here. Just give me a second, sorry. It's this angle right here. That's the angle theta. That's theta. And by the Z law, it's also this angle up here. So you can see why this question is not really for a test. This question actually would have been from an old assignment. So now I can just drop the screenshot of my algebra. So there I got R. And now you can use the circumference formula to calculate the circumference of the Arctic Circle. So if you ever wanted to walk around or navigate around, probably it'd be mostly by ship up there. If you ever want to go around the Arctic Circle, it would be 9,908 miles. So there's your geography lesson for today. This question again is not on the test. I just put it in there for a little bit of a novelty, a little fun time, you know. So it's 8:50. Let's take a break. I'll see you back here at 9 o'clock. So what do you do when the triangle is not right angled? Well, my dear friends, you got to use the sine or the cosine law. So if the triangle does not have a right angle, this is from the earlier page of the document. I'm going to be cutting and pasting this a bunch of times today. Okay, it says here, if the triangle does not have a right angle, then you're going to use either the sine or cosine law, or if you're given all three angles, it's an impossible question. I'm not a fan of impossible questions on midterms or quizzes, so for that reason, I'm not going to play any games with you. The question will have a solution and you can figure it out. So let's take a look here. And I mentioned also that I would give you the diagram, so let me just give you the diagram here. But of course, I know that you are more than capable of drawing these things. It's probably in grade 10 and grade 11, you do this many times in your math class. So there's the right angle, sorry, there's the triangle, which is not right angled. Before you start solving it, and by solving it, I mean finding everything, all the angles and all the sides, you want to look for easy stuff. Like, for example, what's this angle over here? Can someone tell me the angle down there? $34. Thank you, Peter. So how did you get 34? I see someone, Shazad, put 180 rule. That's correct. So you always want to go for the easy stuff if you can. Then after that, you're kind of in the dark in terms of what you have to do. You have to use the sine and cosine law. So let me just put that over there. That's the first thing that you do. So now you have to figure out whether it's sine law or cosine law. So I've made a little flow chart here, or a table, I should say, to help you with that. Okay, are we given three sides on this triangle? Are we given three sides? No. Are we given two sides and an angle in between? No. Definitely not this thing. So it's sine law. So that's the logic that I use, okay? I try to weasel out and filter out what it isn't. And then if you don't get anywhere, it must be the sine law. So now with the sine law, what you want to do is just present the sine law quickly from the notes. Little screenshot here. There's the sine law. You want to consider only two of these at a time. So we have lengths A and C that we want to solve for. So we're going to choose A just because it's alphabetical. It doesn't matter which one you pick. The thing is that this law here can be written in reciprocal form. So you could have it upside down. So I'm going to write the law in reciprocal form in order to solve for A. So there it is. Just writing it down. Sorry, wait, isn't 3.07 for B? Yes. Okay, so the question here, Mario, is labeling. See, big A is opposite to little a. Big C is opposite to little c. And big B is opposite to little b. Got it? So I'm going to, perfect, you're welcome. So I'm going to just write the sine law upside down in reciprocal form. So there's the sine law. And then you can put in all the information. You can put the angle, the sides, whatever. You might be like, Do I need to write it upside down? Well, technically, no. But the reason I do it this way is it reminds me of when I play hockey. I go top corner, okay? I like to put the variable that I want, A here, in the top corner, because then I can cross multiply and solve easier. It's just for me, it's a visual thing. You can just cross multiply and solve. So to finish these questions, top corner, yes. You can always just cross multiply and solve. So I can apply that logic to get the other length C, which would complete the question. So I'll just do that here, a little cut and paste. And a little more cut and paste here. So you can kind of get the feel for how this would work out for other questions. So it's a matter of you just identifying whether it's sine law or cosine law and working with that. Are there any questions about this process? Please let me know. Okay, well, we'll continue with the next one. Let's do one more here, a little bit of extra practice. When I say extra practice, it literally just means that it's the same thing again. So, but I mean, we can still practice. It doesn't matter. So let's take example 11, and I'll give you the picture. If you're wondering how to draw the picture, if you're like, I didn't know to draw the triangle that skinny, so to speak, or oblique, if you want, is the better word. I think what you want to do is just draw any triangle. Just draw an equilateral looking triangle and put the numbers in. And then once you put the 110 degrees, you'll say, oh, that's an obtuse angle. I better open it up a little bit. So you don't have to be you don't have to draw it perfectly the first time, and you don't have to draw it to scale anyway. So that doesn't even. So let's take a look here and see what's going on. Are we given three sides? No. This one's interesting though. We're given two sides, but this is the angle that I'm talking about when it's contained. So there's no contained angle here. So that's a fail as well. And three angles, no, that's not true. So it's sine law. It's sine law. It's the otherwise. Thank you, Ravina. So let's figure out what to solve for here. So what do you think we should solve for, or what can we solve for? What do you think? Yes, angle C. Angle C. Yes, Shazad, you can set that up as part of your solution for sure. So I'm going to put sine C in the top corner, and I'm going to use B because B is fully understood. We know everything about the length and the angle of B. So I can use that information here, put some numbers in, and then you can go on your calculator and actually get C. Now, the key thing here that's important is once you have sine C, you need to use the inverse button. So to get the angle C, you got to use the inverse button. Hopefully that is a reminder, and I did this little blurb here on an earlier question as well. Once you have angle C, the rest of the question unfolds nicely, because then you can finish off the question by finding angle A and side A. That's okay. So now you can finish the question by finding angle A and side A. There we go. Technical difficulty on my part. They're trying to set it up pretty. So that's pretty much the process. Hopefully it's not too much writing. And on the writing note, I should tell you that on your midterm, I promise you that you do not have to solve the entire triangle. You will only get questions in trig where you have to find one thing, whether it's an angle or a side. So I consider this question like a marathon. And in practical sense, it's very rare that you want all the angles and all the sides when you're doing a very simple type of application. If you're talking about solving the truss or solving the forces in a bridge, yeah, you're going to find everything. You're going to find all the sides, you need it all. Too bad. But here, I'm not going to ask you all that stuff on a simple midterm question. So just, it might be just the first step, like find angle C or something. Nothing crazy, okay? So that's question number 11. Hopefully it's not too dangerous. I'll just type something here about 12. No solution for 12. 12 is a redundant question. This is similar to question 10. It's just extra practice. As I said there, okay, extra practice. Oh, that's fine. Okay, so I should say this example. For the sine law, sine A in the numerator and denominator, I mean, the ratio can be reversed. Yes, you can always reverse the ratio because the equation, you can write it upside down or right side up. So you can always write the sine law upside down. So if I go back here, see this thing here? I'll just write it beside it. You could also write it as A over sine. You're most welcome. You can also write it upside down, but we don't want it that way here. Actually, I already wrote it here, actually. We wanted it here, but that's fine. I think I'm talking too much. Let's go to the airplane. So we're going to do question 13. After 13, we'll do a cosine law question, okay? So after 13, we'll do a cosine law question. I'm just going to make a note to myself. So just read this question for a minute, and we'll start taking it up in about, like I said, a minute. Okay, I was just making a note to myself about what to post on YouTube for the missing questions. All right, let's talk about this runway here. So again, if you're given a question like this, I promise you on a test, I would give you the picture. So here's a picture. Oops, there was a picture. It just disappeared when I screenshot it. It's not behaving. There we go. So there is the question. So where is the airplane? Well, let's draw the airplane here. I'm not drawing an airplane. That's a level of service that I cannot provide at this time. So the airplane, guys, I'm sorry, it's a dot. It's a big dot. And the runway, let's make the runway green. Maybe it's made of grass. I don't know. Whatever. That runway is longer than a mile. I'm pretty sure it's not made of grass. So there's the runway. And we also have these things here called angles of depression. Now, angle of depression is the counterpart to angle of elevation. So let's make a note here. Angle of elevation is above the horizon. And angle of depression is below the horizon. Just a quick reminder about that, okay? We always want to measure the angle of depression below the horizon. So for this question, we're interested in that concept. And those angles of depression are 10 and 13.5, which represent the angles that you are measuring out to the line of sight, to the near end and the far end of the runway. Ultimately, in this question, we're just being asked, how far is the airplane from the near end? So how far is the airplane from the near end of the runway? So that quantity is just Z. We're trying to find Z here. Now, you can take that picture and internally do some work, and you'll end up with a much nicer picture, which is this. And that's the picture that I'll use to solve the question. So before we proceed here, just tell me in the chat, why is this 3.5 degrees? Why is this 3.5 degrees? Thank you, Brian. It's the difference. Thank you, Ravina. It's the difference between the two angles. Now, a little bit crusty over here. Why is this 10? Can someone tell the class why that's 10 degrees there? The Z thing. Yeah, actually, Brian, your answer is exactly, look at that. I wrote it backwards. See that? Look at the talent. I wrote a backwards Z. Okay, yeah, so this angle here, up here, is the same as this angle here. And the reason that they're the reason they're the same is because we assume that these lines are parallel. So, I mean, it makes sense. The airplane's level, depression's measured from the horizon, and we're assuming the ground is flat. It's not landing on an incline or something. Well, that would be a different question altogether. So in this case, let's put it all together in terms of our logic. So we have this table here to give us some type of logic. So let's bring that table down here. I haven't really done any math yet. I've just added and subtracted some angles. So anyway, it's kind of cool that you see an application question. It's not about writing a bunch of formulas. It's about really getting clear what the nature of the question is and writing down one key formula to help you solve. So in this case, it's going to be the sine law because we don't have SSS or SAS, and certainly there's not three angles here given. So what you want to do with the sine law is recognize this pattern here that looks like an X. So it'll take me longer to draw this X than to solve it according to my stylus here. Oh my goodness, look at that. Honestly, why? Anyway, you got that pattern there. So we want to solve for Z here. So we're going to put Z in the top corner. And that's the question. That's the answer. Yes, Shazad. Very good. Very good, my friend. I should just screenshot the chat. I could screenshot your chat, and then you guys can type the solutions for me, and I can just drop them in the program here. Check it out. I'm not going to put your name, Shazad, because I don't want to put it on a public domain. I can just screenshot your answer. See? Look how pretty that is. So I'm showing you some respect there. Anyway, let's leave it there. Let's leave it there. I'm gonna put it down in the corner. It's not in trouble, but let's put it in the corner. Okay, let's highlight that. A little trimming. There you go, my friend. You're famous now. Or you're famous already. I don't even know. Alternate angles are equal. Yes, the Z law. Yes, the alternate angles. Yes. Okay, so that's enough of sine law. By the way, 3 significant digits in the bubble here. That's why it says 23,500, because we want 3 sig figs. So anyway, I'm just fixing my microphone for a second. Okay, so let's take a look here. Okay, 14. I'm going to put the solution to this one on YouTube at the end of the video. That's what I was making a note. I answered this question with another section, so I will post the solution to this question. You'll have to watch the video for that one probably. If we have time, we'll cover it, but I need to cover other ones too. I'm kind of mixing and matching with the different sections. So the next section that I have in mind, sorry, the next question is to talk about cosine law. So here's a little decision table, and let's just copy this decision table over here as well. So we're going to discuss cosine law for a few examples. Make sure that we are fully clear about what to cover. So let's take a look at example 16. So again, don't stress too much right now about how to draw the picture, because in an evaluation I would give it to you. But when you're doing your homework questions, be sure to do all of the questions and draw it yourself to practice that skill. To review that skill, I should say. It should be familiar to you. Anyway, here's your triangle. So let's go through our thinking process here. Are we given 3 sides? Are we given 3 sides on this triangle? Nope. Thank you, Dogan. Welcome to the show. There you go. Nothing happened in there. How about this? Are we given this? SAS? Is that true? Yeah, it's cosine law. Thank you, Ali Akbar. Yes, thank you, sir. Oh, there you go. Okay. Yeah, because you got side, angle, side. You see they're all together? I want you to think of lunchtime. It's a sandwich. Okay? This angle has to be sandwiched in between. Now, if you don't like the word sandwich, the word here mathematically is contained. Okay? Contained, think of a sandwich. Anyway. So forget about this garbage down here. We don't need it. Just hack it away there. Whoops. Okay. I got a little bit excited. Hang on. All right. So anyway, we're going to use the cosine law. So I'm just going to drop a cosine law on you. So yeah, actually, you're a boss. You're just a boss, Shazad. That's awesome. I would have screenshot your thing there, but I need all the letters first. So there's the cosine law. Now, what's important here to note is that the letter here, the variable for the length here, A, has to be the same as the letter at the end. This letter here has to match that letter there. If they don't match, then you haven't presented the law correctly. Subsequently, the other variables here, B and C, it doesn't matter if it's B and C or C and B, because they're added here and they're multiplied. And as you know, addition and multiplication doesn't matter the order. So there you go. Now, it turns out that the cosine law can be written a different way. You could write it this way as well. Now, because your test is open book, I would have both versions of the law handy, because I don't know if you get a cosine law question, which one it's going to be. I don't remember anyway. So I think that this one over here, I'm just going to put it on the side and have it on standby. Maybe it helps us with the next question. I don't want to like cheat, but I do think it helps with the next question. As you've seen, I'm not doing duplicate questions in this presentation today. So anyway, we're back here. Now I like this one. I really like this one and I'm going to give it a happy face. Whoops, I was going to give it a happy face. There we go. Because there's something nice that happens here. When you put all the information here, let's toss in all the numbers, and I could have copied and pasted what Shazad had, but I just noticed that I want to put all the numbers here. See, look, all the numbers. So why did I put a happy face? Someone me in the chat, why am I happy about this? Let's give the happy face like a head. Ah, forget it. Oh, God bless you there. Yeah, no rearranging, right? Okay, no rearranging. What is that? Is that like a horseshoe? I don't know. Anyway, yeah, no rearranging here. Big math. So anyway, I want to put a funny meme. That's okay. I was gonna drag and drop a funny meme there. Anyway, yeah, this is all numbers. See, you might be aware, or you should be aware. You should be aware that that your calculator understands bed mass. Your calculator understands bed mass. See all this stuff here? If anybody in this group is typing this with baby steps, like this thing and they write it down, this thing they write it down, this thing if you do that, you're gonna run out of time. What you want to do is have faith in your calculator that you can just type all this crap in there. Just type the whole thing the way you see it. Give it a shot. Give it a shot today. Try that. Type the whole thing in there and see if you get the answer. Because if you do, then you don't have to waste as much time on this step. Anyway, there's the answer. A squared is 1, 2, whatever, 593. But remember that you got, thank you. So remember that you got to go from here to here. Don't forget that square root. Let's put it in green. Don't forget that square root, okay? And then, okay, what's going on here? Why decimals and then why simplified? This is my answer. This is the one that I would put in an answer key. But this answer here is needed for future work. See, we're not done the question. We still have to solve the rest of the triangle. So we need a more accurate number to carry over the future steps. So to complete the solution, just use the sine law and the 180-degree rule. Intermediate steps, Ravina, I usually say 2 extra digits is good. But honestly, that's more for practical reasons. For this course, I'm not going to be too mean because of the format of your tests. But in practice, I always try to keep a couple extra digits. You're welcome. And that's just from my, I mean, you know, we could have a debate about it, but that's just from my engineering background. So I'm just going to write down the rest of the solution here, but I'm not going to discuss it. So for the rest of this solution, people, I'm not going to discuss that part because it's sine law. And we've done that a few times already earlier in the lesson. So what you see is it's kind of like once you get past the first step, the rest of the solution is the same. I should mention one more thing here. Use cosine law at most once. The reason is it's expensive. It's a lot of writing. Even with the shortcut formulas later, it's still a lot of writing. It's too much work. So you don't want to waste a lot of time writing down stuff with cosine law. So like you could finish the question with like extra work there, but you're probably wasting time. So let's take a look at question 17. And 17 is the other variation of the cosine law, where you're given 3 sides. So there's a triangle with 3 sides. And in this case, let's just label those 3 sides. See, it's this case right here. No, it's okay, Ravina, because it's not 3 angles. It's 3 sides. It's all good. So this is the rearranged formula of the cosine law when you want to solve for an angle. Now I've set it up to solve for angle A. See angle A right here? But you could also solve for angle C or angle B. It doesn't matter which one you decide. For very small reasons, very subtle reasons, if you're not sure, or if you ask me what's the best choice, I usually go for the largest angle because there might be occasions where the triangle is very oblique and you might get rounding issues. So I always go for the largest angle, which is in this case C. So although this law is presented here like this, I'm not going to use these letters. I'm going to use the variables as per the rearranged version of the cosine law. So let's do that now. So see, I'm solving for C instead. I'm going to find angle C. So the first step is to do this. Now, when you do that, you get, after you complete the evaluation there, you get cos C equals negative 0.76, whatever it says there. And then you can use inverse cosine to finish. Okay, once you have inverse cosine done, and you got the angle there, then you can finish the question with sine law. So it becomes the same thing again. Yeah, Mario, if you did it the other way, you'd still get the same answer, okay? Yep, you get it the other way if you use the alternate formula. Yep. Absolutely. You're very welcome. Okay, so that completes the so to speak prerequisite kind of all the versions of algebra that you need. So we have some time left that I'd like to dedicate toward application questions, but I'll choose ones that I haven't covered with other sections so that you can have a variety of answers. So I'm just preparing a little note about which ones to cover. We're going to do question 20. I haven't covered that one with any sections. And then after that, I think we're going to go back and maybe do another one. So here's the question. Just give it a read for a minute, and then we'll talk about it. Okay, it looks like we're trying to calculate an angle. We're given some type of a diagram, or sorry, you would be provided with some type of a diagram in the test setting at least. So let me draw the diagram here. So there's the diagram. So what the heck is happening there? What are we trying to calculate here? That's right. We're trying to find that angle there. We're trying to find the angle. Okay, so it's interesting. We want to find the angle between the plane's directions to Detroit and London. So it's angle P. See, this is the direction that. It's the angle between those two line segments. So in this case, we want to find this angle. What are we given on the triangle? It looks like we're given 3 sides. So that's Cosign Law. Okay, there might be people in the class that are like, do I need to use SOHCAHTOA? Let me comment about that here. That's my comment there. Anyway, we're going to use the Cosign Law, and Ravine actually typed the formula already, which is fantastic. So I'm just going to steal her formula. Don't mind. I'm having an issue with my screenshots, my screen capture. So there's the formula. If you don't mind, I'm going to type it out with the appropriate math feature here. Actually, it's kind of funny is I can actually copy and paste your chat. I'll copy and paste your chat right here. Let's see if this works. Okay, it doesn't like it. It's not nothing wrong with you. It's just the chat's funny. Okay, there's the formula. And then you can plug all the numbers in. Oh, you're very welcome. So, cos P. Okay, we have your, help me out, people. Was that 190 squared plus 110? Correct anything I'm doing here because I'm just winging it. Right, so that's what I got. Seems to be okay based on the feedback. So you can solve for cos P because this turns into a decimal. So earlier when I did this, I got this 54067. Okay, at that point, you can just solve it. Looks like my screenshotting tool is not working correctly now. Anyway, you get 57 degrees, 57.3 degrees. So that represents the angle between the two. I don't want to say position vectors because you haven't talked about vectors. But we will be talking about vectors next semester. So for now, I'm just going to say it's the angle between the plane's directions to Detroit and London, respectively. Awesome. Same answer. So that's pretty much that's the application question for cosine law that I wanted to cover. Now we're definitely we're going to try another question. I want to make a note about question 21. So I'll just give you a little bit extra time there to take down what you need to take down. And then we'll talk about 21 very briefly. Okay, I'm going to take you back here. So question 21. This question is not on your test. I'll just say here for the stronger students, fun question to do. For all students, a very practical question to do. I would mention here, I'm not saying that if you don't feel that you're that strong with trigonometry, that you shouldn't do the question. I'm just saying that the question is maybe not a quote-unquote fun. So maybe I should just say here for students, maybe I should say a fun question to do. And but a very practical one nonetheless. Anyway, all jokes aside, I'd like to do one more question with you, and then we can move on to the actual quiz. So anyway, okay, I think we're in business now. I just want to do that one question. So let's dig back here to this one. So this is a physics type question. Now, I'm not teaching you physics here. I will be teaching you a lot of physics next semester. But all I want you to do right now is just learn a little bit about how you can use a force diagram. So again, if this is a test question, I would give you more information, or at least cover something like it in class, which is what I'm trying to do. So anyway, we want to find the forces in the cables T1 and T2. So I'm asking you, which force do you think is bigger, T1 or T2? Which one do you think is greater? Yeah, Ahad, Kiara, Travina, perfect. Yeah, T1 is bigger. Now the reason that T1 is bigger may not be obvious to people, but the cheap answer is that it's a shorter rope, but also it's more vertical. The force that is more vertical is the one that has the larger force, or carries the larger of the burden between the two. So what I just did there was I tried to remove the physical part, which was the actual roof, and I'm going to put some arrows here. So this represents what's called a force diagram or a free body diagram. In this course, I'm not asking you to draw free body diagrams, although next semester you will have to learn how to draw these kind of pictures, but nothing too dangerous. Yeah, the crate is also closer to T1. Yeah, you could argue that too as well, Ravina. It's on the nature of that the rope is shorter. That's another reasoning. That's very good comment. I want to mention something here. Okay, so for equilibrium, so I'm just going to type it. Okay, so there's a little comment. For people that have not studied physics, this is kind of like my cheap version of what you do for questions like this. So we say this is an equilibrium. And all equilibrium means is this thing's not, if you press play, if this was an animation and you press play, this thing is not going to move. Because if it moves, it's not an equilibrium. What I'm talking about is static equilibrium. So let me put here the word static, meaning not moving. You can have equilibrium moving with a constant velocity, but that's not for this course either. Because we build things in construction that are not designed to move. So we want the building to stay still, for the most part. Anyway, we have to do this type of thing here. Or there's other ways to solve it, which I'll teach you next semester. So let me teach you a way this semester that's really cheap. And it just involves what I said there. Draw the numbers in a closed loop. So let's take a look here. So see this guy here? It's going down. Whoops, it's not even there yet. I have to draw it. There it is. And I just put it here now. So now it's here. And this guy goes this way, so I just put it here. And then this guy goes this way, so then I go back here and I come back home again. You see, you go in a loop. It's a closed loop. It's like you're going on a journey and you finish where you start. So now that you've completed that loop, now you have a triangle. And you can solve the triangle like you can solve other questions. Yes, the head to tail rule, Shazad. Thank you for that. I'm trying not to say any physics things, but yes, head to tail, yes. So let's talk about some of these angles. So if we can identify how these angles on the figure were found, then we can solve here. So I'm gonna, because we're running out of time, I'm gonna just reveal it here, because normally I would ask you. There's a Z law there. See that Z law, the 42? I can draw the exact same Z right here. So that's how I get that 42 and that 42. I can also do a Z law here with a 30 kind of backwards Z. Well, that's a forward Z, I guess. Like that. So that's 30 and that's 30. And I can repeat that Z right here. Oops. Like that. So that's 30 and that's 30. And that's how I synthesize all of those angles. Now, on the diagram, there's additional angles, 60 and 48. The way that I got 60 and 48 is because of a 90-degree right angle here. See, this is 90 degrees, and that's 90 degrees. So 60 plus 30 is 90. 48 plus 42 is 90. So that's the logic of setting up the triangle. Once you have set up the triangle, you are in, the coast is clear. The coast is clear and you can solve. So you can use the sine law here. So I will use the sine law here because you don't have three sides and you don't have two sides at an angle in between. So that's why I wrote down the sine law. Where did it go? My sine law just disappeared. So there it is. There's your sine law. And to solve for T1 and T2, notice that I wrote it as a triple. But you can always think of it two at a time. So if I take these two guys here, I can solve for T1. And then if I take these two ones over here, slow motion, sorry. If I take those two over there, I can solve for T2. And I'll just drag and drop my solutions for T1 and T2 so that we can wrap up this lesson. So there's T1, and there's T2 coming up shortly. So there's T1 and T2. Notice that T1, as we predicted, based on just intuition, T1 was greater than T2.